Hello and welcome to MoveIt Weekly. I'm Tyler from Picnic Robotics, and this week I'm going to show you Generate Parameter Library. So, Paul was an intern at Picnic Robotics this summer and ran into an issue that many of us at Picnic Robotics have run into before, and that is using the parameters API and RCL-CPP results in lots of boilerplate, at least the way we tend to use parameters, and it's easy to make mistakes, especially when it comes to working around dynamically updating parameters and declaring parameters with descriptions and doing validation. It's a lot of code, and a lot of it is basically copy paste. So Paul ran into this and kind of took a new approach to this than what I had previously tried. Was to use a more powerful tool. I made a joke that it was a more violent approach. Um, he used code generation. And at first I was skeptical, but I came around to it, and I think it's a great solution that provides a really nice user interface, and it's easy to use, and it's pretty hard to misuse. It takes this boring thing and keeps it boring. Like, parameters should not be a thing that results in you shooting yourself in the foot or spending a lot of time debugging. Like, parameters should be just boring. Anyway, so the way you make parameters boring is you make them declarative. And one way to do that is to move from something imperative, like writing code, to something declarative, like a config file. And as many ROS users are already familiar with YAML, and YAML tends to be the language of configs in ROS, we use YAML as an input. So here is an example YAML input to generate parameters library, and it starts with a namespace. We did this. This root element is a namespace. The reason we did this, and you can only have one root element per library, is you could have multiple of these linked into the same project, and they wouldn't conflict as long as you had different namespaces for each set of parameters. This is an example of a namespace in your parameters. You've probably already done that or used that feature. And then these are individual parameters. In this case, R, G, and B are like red, green, and blue 8-bit values with bounds checking, inclusive 0 to 255. All right, how do you use it? You add this to your package XML. Currently, this only works in Humble and Rolling, where we've released it. It could be backported, but as we tend to do all of our work in the latest version of ROS, this is the only place we've released it because that's the only place we're using it. You're going to call find package on this in your CMake, and then you're going to call generate parameter library. It's a CMake function that takes at least 2 parameters. The first is the target name for the library that it's going to create, and the second is the YAML file input relative to the root of the source in your CMake project. Then here's an example using it in an executable and calling target link libraries to include it. It's a library after all. You can also export this library as part of your export set if it's part of your public interface. To use it in your C++ code, here's an example. Note this turtlesim parameters.hpp that is included. This library is a single header library, and that header is the name of your generated library, and then .hpp because it's a header file. Then to use it, you need to create a parameter listener, and it has a single argument. It's the parameter interface, but we provide a couple convenience constructors that will take an RCL-CPP node and call get parameter interface, or taking a lifecycle node and also calling get parameter interface. It really only cares about the parameter interface from RCL-CPP. Here is the type. Note the namespace turtlesim that came from the YAML file, and then you're creating a parameter listener. The reason for this object is it needs to have a updater function that it gives to ROS to be able to validate parameters that are coming in, and that object needs to have roughly the same, or it needs to have the same lifetime as the node object. So in our example, we are creating it right after the node in our main, so it has the same lifetime as the main, or as the node. If you're creating a component node where you inherited from node, for example, you would put a parameter listener as one of your members, and you would construct it in the constructor, handing the node to it. If you did a lifecycle, you might do it in the on init. And then to get a struct that represents the current state of your parameters, you just call getParams. Then, as an example, here is logging the values from the parameters. You can also use this in your tests. Dennis was really gracious to provide a pull request that added this functionality to these two functions: add ROS test with parameters gtest, as ROS test with parameters gmock. This is especially useful when you have parameters that are required but do not specify defaults, because starting a node or creating an object that then creates one of these parameter listener objects, unless the parameters have been specified as command line arguments through the same way that ROS expects all of its parameters on initialization, it will fail or throw an exception actually more accurately. Thank you for watching. I hope this has been interesting. If you want to use it in your projects, feel free to use it. It has a permissive license, and I'll see you guys next week.